This is the 310 to 311 review. Number 1, calculators are not allowed. In the triangle shown below, theta is increasing at a constant rate of 2 radians per minute, and the question is, at what rate is x decreasing in units per minute when x equals 12? So this is a full-on related rates problem. Our first step is to draw a diagram, which is already drawn for us, and we can write down that we know d theta dt and that we want dx dt. So the second step is then to write an equation that involves theta and x. Looking at the right triangle here, we can see that the relationship that's going to be involved here is a trig relationship. And cosine is the ratio that we will use because we have the adjacent side and we have the hypotenuse. So for step 2, we can write the cosine of the angle is the adjacent, which is x, over 13, which is the hypotenuse. Step 3 is now to take the derivative of each of these with respect to theta, or excuse me, with respect to t, because the things are changing over time. When we do that, we will get the derivative of cosine, which is negative sine of the inside unchanged, times the derivative of the inside. And on the other side, oops, forgot my x over 13. On the other side, we have a constant, which is 1 over 13. Coefficient we move through, then we hit the x. The derivative of x with respect to t is 1/13 dx dt. So step 4 is we go back to the picture and we label it with what we know at the instant. So at the instant, we know that theta is increasing at 2 radians per minute, and we also know that x equals 12. So the other variables that are going to be involved with step 5 are theta, and that's it. So we can either find what theta is, or we can determine what the sine of theta would be. Since we don't have a calculator, computing theta is going to be a bit out of our ability range, so instead we can use the fact that this is a Pythagorean triple and the opposite side will be 5. So now I can compute the sine as a 5 over a 13. So for step 5 now, I can write negative sine of theta, which is 5 over 13, times d theta dt, which is 2, will have to equal 1/13 times dx dt. If I isolate dx dt, which is step 6, I will multiply by 13 and get negative 10, and it looks like units per minute. So step 6, we've isolated. We also want to interpret, so we can say x is decreasing at a rate of 10 units per minute.